I am Suresh Kannan, working as Assistant Professor in PSN College of Engineering and Technology. My topic is communication and amplitude modulation. So, first one, communication. Definition of communication. First of all, we will discuss about define communication or what is communication. It is the process of transferring information from one place to another place. This is called as a communication. So it is also the process of establishing connection between two points for information exchange. So we know that communication means it is a transfer of or exchanging the message or information from one place to another place. It is called as a communication. So this is the block diagram of communication, which consists of, there are different blocks: information source, transmitter, channel with the noise, receiver and destination. Now we will discuss about the information source. So these are the components components of communication system: information source, transmitter, channel with the noise, receiver and destination. Information source, it generates the data or message to be transferred. The message can be audio, video or image signal. The inputs transducer is used to convert message signal into electrical signal. This signal is called as baseband signal. Example, human voice. It is in the analog form, audio, video, text, etc. In the digital forms, we know that binary digits, ones and zeros, that is utilized in the computer data. This is the information source. Transmitter, it converts the message signal into suitable form of the signal to over the communication medium. It is used to convert the information into a suitable electrical signal for efficient transmission. This is achieved by modulating the carrier signal, which is called electromagnetic wave or radio frequency wave. It is the combination of modulator, amplifier and a transmitting antenna. These are the blocks which contains in the transmitter. The input of the information source is given to the transmitter block. The output of the transmitter block is given to the communication channel with noise. Transmitter and receivers are usually separated in space. The channel provides the connection between source and destination. The channel can be in the form of coaxial cable, fiber optic cable or air. It is the transmission medium by which the signal is sent from the transmitter to receiver. The channel, it is the middle part of the transmitter and the receiver, which is having the transformation of the signal from transmitter to receiver. It is having two types. One is wired channel and wireless channel. So wired channel, which is coaxial cable or optical fiber cable. In wireless channel or communication, mobile or satellite communications, we are using for radio frequency signals by using air is the medium. So this is the wired channel. So it is the transmitter to receiver with the help of the wired connections is as a medium in the channel. So it is simple wires, that is coaxial cables, waveguides, optical wires, that is fiber optic cable. So we are using wired channel, coaxial cable and optical cable in between the transmitter and the receiver as a channel. So wireless channel or wireless communication, signal is transmitted through free space in the form of radio waves. Example, radio or TV broadcasting, satellite communication, mobile communication, etc. Here the diagram is representing the transmitter with the transmitting antenna and receiver along with the receiver antenna, both connected by using through the free space in the air is a medium of the wireless communication system or wireless channel. So noise is the random or unwanted signal. It gets added to the desired signal while transmitting through a channel. Distortion is the process of changing the shape of the information signal or original signal or message signal. So noise is also called as a distortion, which is the interference of the message signal, or the message signal can be a message signal of the shape can be changed with respect to the noise. Receiver reconstruct the original message signal from the received signal. The function of the receiver is extracting or receiving the message signal from the degraded version of the transmitted signal. So here the receiver, which is only message signal, along with the high amplitude signal. The transmitter and the receiver are designed to avoid the distortion and minimize the effect of noise from the receiver. The combination of receiver, which has the demodulator, amplifier and filter. So this is the diagram is representations for receiver. The input of the receiver is the information signal along with the noise signal, and the output of the receiver is original message signal. So destination, it is the received signal is to reconstructed the form of original signal and delivered to the destination. So these are the block diagram of communication system. So next we will see the amplitude modulation. So amplitude modulation, first of all, modulation, there are three types of modulation: amplitude modulation, frequency modulation and phase modulation. Now we are going to discuss about amplitude modulation along with its derivation. Amplitude modulation, it is a process in which amplitude of the carrier signal is changing with respect to the amplitude of the message signal, keeping the phase and the frequency of the carrier signal is constant. It is used in transmission of audio and video signal and two-way mobile communication system. The modulating signal is also called as baseband signal or audio frequency signal. The message signal contains some useful information. The carrier signal is high frequency or radio frequency signal. So types of amplitude modulation. There are four types of amplitude modulation. First one is the amplitude modulation with the carrier. Second one will be double sideband suppressed carrier or DSB-SC amplitude modulation. Third one will be single sideband suppressed carrier or SSB-SC amplitude modulation. Fourth one will be vestigial sideband amplitude modulation, that is VSB-AM. These are the four types of amplitude modulation. So graphical representation of the amplitude modulation. This is the graphical representation which contains information signal or message signal, carrier signal and the amplitude modulated signal. So the information signal, it is a low frequency signal which has the low frequency along with the less amplitude, and a high frequency signal is called as a carrier signal. It is high frequency and a constant amplitude of the waveform signal. The amplitude modulated signal, which has the envelope shape of the amplitude modulated signal. So this is the envelope shape of amplitude modulated signal. So the message signal is also called as a baseband signal or modulating signal. This message signal is low frequency as well as the maximum amplitude of the message signal is plus Vm and the minimum amplitude of the message signal is minus Vm. So here Vm is maximum amplitude of the message signal and the minus Vm is minimum amplitude of the message signal. The message signal is a low frequency or a baseband signal or modulating signal. So it is a sinusoidal wave, so it is represented by Vm sin omega m entity. Here the Vm is called as a amplitude of the modulating signal. Omega m is the angular frequency of the modulating signal, and T is represent the time period of the signal, and it is sign represented as sinusoidal waveform. So this is the equation which is used for modulating signal. So next one, the carrier signal, we are going to modulate the message signal along with the help of carrier signal. Carrier signals are nothing but the generated waveform, that is high frequency signal is called as a carrier signal along with the constant amplitude. This carrier signal having constant amplitude and high frequency. Since the frequency is very high, the time period will be very small. So we are drawing with minimum time period. The AM signal happens with the carrier signal and the message signal. The superimposition of message signal over the carrier signal is called as amplitude modulation. The amplitude of the carrier signal increases or rises when the message signal goes positive. Amplitude of the carrier signal reduces when the message signal goes negative. The envelope of the AM represents the message signal. Now we will discuss about the derivation of amplitude modulation. Let us start with the message signal. The message signal or modulating signal is represented as Vm of t is equal to Vm sin omega m into t, where Vm is the maximum amplitude of the message signal, omega m is the angular frequency of the message signal. The carrier signal is also a sinusoidal waveform. The instantaneous sinusoidal waveform carrier signal is represented as Vc of t is equal to Vc sin omega ct. Here Vc is represent the amplitude of the carrier signal and omega c is represented as the angular frequency of the carrier signal. T is represented as the time period of the carrier signal. In carrier signal, amplitude is constant and the time period will be changing. As per the definition of the amplitude modulation, the amplitude of the carrier signal is changed after the modulation. The change happens in this way, amplitude modulated waveform. So now we'll see the derivation. Vam is equal to Vc plus Vm of t, which is equal to Vc plus, we have to substitute the value of Vm of t is equal to Vm sin omega m into t. So take the value of Vc in outside. Therefore 1 plus Vm by Vc sin omega m into t. So Vc into 1 plus Ma sin omega m into t. Here the Ma is represented as ratio of Vm by Vc, that is Ma, that is called as Ma is equal to Vm by Vc, is called as modulation index or depth of modulation. The modulation index is the ratio of amplitude of the message signal to the amplitude of the carrier signal. So here Vm is represented as the amplitude of the modulating signal. Vc is called as the amplitude of the carrier signal. The ratio of Vm by Vc is called as a modulation index or depth of modulation. The instantaneous amplitude of modulated signal is Vam of t is equal to Vam into sin omega c into t. Now we derived the value of Vam is equal to Vc into 1 plus Ma sin omega m into t. We have to substitute the value of Vam, this equation, in this Vam of t. So therefore Vam of t is equal to Vam into sin omega ct, which is equal to Vc into 1 plus Ma sin omega m into t into sin omega c into t, which is equal to Vc. Now we'll multiply the values of Vc sin omega c into t plus Vc Ma sin omega m into t into sin omega c into t. Now we'll be substitute the value of trigonometry equation, that is called as a sin A sin B is equal to cos A minus B minus cos A plus B by 2. Vam of t is equal to Vc sin omega ct plus Vc Ma by 2 into cos omega c minus omega m into t minus cos omega c plus omega m into t. Now we'll further simplify the above equations. Vam of t is equal to Vc sin omega c t plus Vc Ma by 2 cos omega c minus omega m into t minus Vc Ma by 2 cos omega c minus omega m into t. This will be getting 3 times, means the above amplitude modulated signal consists of 3 times. The first term is called as Vc sin omega ct, is the carrier signal or high frequency signal. The second term is Vc Ma by 2 cos omega c cos omega c minus omega m into t. This is the LSB or lower sideband signal. The third term is Vc Ma by 2 cos omega c plus omega c into t, that is called as upper sideband signal. Here we are using omega c plus indicating upper sideband signal and omega c minus indicating lower sideband signal. This representation is the time domain representation of amplitude modulated waveform. The carrier signal and message signals are superimposed, and particularly in the carrier signal. So now the derivation of amplitude modulation has been completed. Now the equation is represent the final equation of amplitude modulated wave is equal to VAM of t is equal to Vc sin omega c t plus Vc Ma by 2 cos omega c minus omega m into t minus Vc Ma by 2 cos omega c plus omega m into t. So amplitude of the amplitude modulated waveform is identical to the amplitude of the message signal. When the message signal is absent, means that is Ma is not present, that is Ma is Vm by Vc. It is called as modulation index. If Vm is 0 or message signal is absent, then it will be getting only the carrier signal. This is the frequency spectrum of amplitude modulated wave. Here we are representing the in x-axis omega, that is called as angular frequency. In y-axis is represented amplitude of the signal. So here LSB is omega c minus omega m, that is lower sideband signal. Omega c is called as carrier signal. Omega c plus omega m is called as upper sideband signal. So in omega c we are using Vc. Vc is called as amplitude of the carrier signal, and omega c is the angular frequency of the carrier signal. In USB upper sideband, omega c plus omega m is called as upper sideband, and Ma Vc by 2 is called as amplitude of the upper sideband. Similarly, in lower sideband also will represent Ma Vc by 2. This is called as frequency spectrum of amplitude modulated wave. Here the parameters of frequency spectrum, omega c is equal to carrier frequency, Vc is the amplitude of the carrier signal, omega c minus omega m is the lower sideband frequency, Ma Vc by 2 is the amplitude of the LSB, and omega c plus omega m is upper sideband frequency, Ma Vc by 2 is the amplitude of the upper sideband. We know that bandwidth is difference between the upper cutoff frequency to lower cutoff frequency. The bandwidth is equal to upper cutoff frequency minus lower cutoff frequency, which is equal to omega c plus omega m minus of omega c minus omega m, which is equal to omega c plus omega m minus omega c plus omega m. You see here minus omega c plus omega c will be cancelled. The remaining term will be 2 omega m. Therefore, the bandwidth is the twice of the time the frequency of the message signal. So now we have completed about the derivation of amplitude modulation signal, modulated signal. Next we will see about generation of amplitude modulation. So in generation means it is also called as modulation of amplitude modulation. Next we will see about demodulation of amplitude modulation. So generation of amplitude modulation wave, the circuit is used to generate the amplitude modulated wave is called that amplitude modulator. So the types of amplitude modulation there are two types of amplitude modulation in modulator. First one is linear modulator or high level modulator. Example is switching modulator. Second one is non-linear modulator or low level modulator. Example square law modulator and balanced modulator. So these are the types of AM modulator. First one we'll see switching modulator. A simple diode can be used as an amplitude modulated switching modulator. Amplitude AM switching modulator. Switching modulator is a linear modulator and the generation of AM wave takes place at higher power levels. This is the block diagram or circuit diagram of the switching modulator which consists of message signal or modulating signal and along with the carrier signal and diode and the resistance. So these are the different components of the switching modulator. Here we are representing M of t is equal to AM cos omega m into t. C of t is equal to AC cos omega c into t. So here we are representing M of t is a low frequency signal and C of t is the high frequency signal. So we are combining C of t and M of t two signals, and V1 of t is the combination of M of t plus and C of t. So next, the input of the diode is the sum of M of t and C of t. The diode which operate as a switch, open switch or closed switch, and the output of the diode is connected into the resistor. The output of the total value is V2 of t. So this is the circuit diagram of switching modulator. C of t and M of t is connected in series, means we are combining two signals, low frequency signal along with the high frequency signal. So the total output of V1 of t is equal to M of t plus C of t. So here M of t plus the value of C of t is equal to AC cos omega ct. We are substituting the value of AC cos omega ct. So the total voltage V1 of t is equal to V1 M of t plus AC cos omega ct. During positive off cycle of the carrier signal, the diode is forward bias and it acts as a closed switch. Therefore, the diode is on. This is the working principle of the switching modulator. So here we are explaining about only positive off cycle of the carrier signal. So here positive off cycle of the carrier signal, the diode is forward bias, means the diode is connected, positive terminal of the diode is connected to the positive part of the carrier signal, positive wave of the carrier signal. So the diode, it acts as a closed switch. Then the diode is on condition. The output of the diode is same as the input. So the total output across the diode is V2 of t is equal to V1 of t. Similarly, during the negative off cycle of the carrier signal, the diode is reverse bias, means and it acts as a open circuit. Therefore, the diode is off. The diode will not conduct in negative off cycle of the carrier signal. Therefore, the output voltage V2 of t is equal to 0 because the diode is open circuit. During negative off cycle, diode is open circuit. Therefore, the V2 of t is equal to 0. During positive off cycle, the diode is closed circuit. Therefore, the output V2 of t is equal to V1. This is two conditions satisfied during this switch function. So the diode here, the diode is working as a switch. The switch can be either open condition or closed condition. During the open condition, means during the positive off cycle, the diode acts as a closed switch, and during the negative off cycle of the carrier signal, the diode is act as a open switch. That's all. So there are two cases we are using. C of t is the carrier signal which is positive. C of t is greater than 0, and C of t is negative. C of t is less than 0. So this is the graphical representation between V1 of t and V2 of t. So C of t is greater than 0, then the slope is equal to 1. C of t is less than 0, means the wave follows in the x-axis. So this is the representation between V1 of t and V2 of t, the output voltage V1 of t and V2 of t. The V2 of t is equal to V1 of t C of t greater than 0 and V2 of t is equal to 0, C of t is less than 0. The total output is given by V2 of t is equal to V1 of t Gp of t, where Gp of t is the pulse train. The Gp of t is a periodic pulse train of duty cycle equal to half period T0 by 2. Here T0 is called as duty cycle. So we know that periodic pulse train or rectangular pulse waveform. Pulse means it is a combination of zeros and ones, that is called as a pulse train. So here the example, the representation of pulse train. So here in x-axis it represented the time and y-axis is represented as a amplitude. It is represented as Gp of t. So 0 in positive half cycle T0 by 4 and T0. T0 is called as duty cycle and minus T0 by 4 in the negative half cycle and minus T0 is called as a duty cycle of negative of the pulse train. Based on the Fourier series, we can represent the Gp of t is the diagram is it is the pictorial representation or waveform of the Gp of t. Here we Gp of t we are using for Fourier series equation. Gp of t is equal to 1 by 2 plus 2 by pi summation n is equal to 1 to infinity minus 1 the whole power n minus 1 divided by 2n minus 1 cos 2n minus 1 into omega c into t, which is equal to 1 by 2 plus 2 by pi cos omega c t plus odd harmonics. So here we are neglecting the value of odd harmonics. Substitute the equation 1 in 2. So the V2 of t means output of the switching modulator V2 of t is equal to m of t plus AC cos omega c t into the pulse train value Gp of t. Substitute the equation 3 in equation 4. V2 of t is equal to m of t plus AC cos omega c t into 1 by 2 plus 2 by pi cos omega c into t. So here we are substituting the value m of t by 2. Multiply the equations m of t in remaining term and the AC cos omega c t into remaining terms. So the final value of the V2 of t is equal to m of t by 2 plus AC by 2 cos omega c t plus 2 by pi m of t cos omega c t plus 2 AC by pi cos square omega c t. So these three equations or these three terms which is represented as modulating signal is called as m of t by 2, AM signal which is called as AC by 2 cos omega c t plus 2 by pi m of t cos omega c t. Harmonic values are 2 AC by pi cos square omega c t. These three terms are called as modulating signal, AM signal and harmonic signals represent respectively. So next we will discuss about the another type of AM modulator. It is called as square law modulator. So it is also one of the type of linear modulator or AM modulator. So this is the circuit diagram of square law modulator. Here we are using x of t is represented as modulating signal or message signal and the carrier signal is C of t. It is EC cos 2 pi fc into t. Here 2 pi f is called as omega. Omega is equal to, we know that the omega value is equal to 2 pi f. So here 2 pi f C means a carrier signal. And the non-linear device, we are using diode as a non-linear device and V1 of t is equal to the combination of x of t and C of t and V2 of t is the output of non-linear device. Then the V2 of t is given to the tuned circuit, or tuned means tuned circuit. It is a combination of a capacitor and inductor. Here the tuned circuit we are using in the acting as a band pass filter. So output of the tuned circuit is connected to the transformer and resistive load we are connecting in the transformer. The total output of the square law modulator is VO of t. VO of t means total output of the square law modulator. V1 of t is called as the input of the non-linear device. V2 of t is called as the output of the non-linear device, and VO of t is called as the output of the square law modulator. So the square law modulator is a low level modulator which is AM wave can be generated at low power level, means the value of power will be very less. It is not as a high power signal. The modulating and the carrier signals are connected in series with each other. The sum of M of t and C of t is given to the non-linear device. So we know that M of t is the modulating signal or baseband signal or low frequency signal. M of t, the equation of the M of t is equal to AM cos omega m into t. The equation of carrier signal C of t is equal to AC cos omega ct. Then the V1 of t, which is equal to the connection or combination of M of t plus C of t is called as V1 of t. So V1 of t is equal to, we are substituting the value of M of t and C of t in V1 of t. Therefore V1 of t is equal to AM cos omega m into t plus AC cos omega c into t. Here AM is represented as amplitude of the modulating signal, omega m is represented as angular frequency of the modulating signal, and t is called as time period of the signal, and AC is called as amplitude of the carrier signal. Omega c is called as angular frequency of the carrier signal. So the non-linear device, it is used to implement square law modulation. In square law modulation, we are using a non-linear device as a semiconductor diode or transistor. A simple diode can be used as a non-linear modulator by restricting its operation to a non-linear region of its characteristics. We know that in semiconductor, diode and transistors is a basic components of the semiconductor elements. Diode is the two-terminal device, as we know that. So we are using anode terminal and the cathode terminal. So by using this two terminal, we are using input of the diode. We are using two signals as a message signal and a carrier signal, and output of the diode we are taking the combination of both the message signal and the carrier signal. In general, transistor is a three-terminal device which consists of base terminal, collector terminal and the emitter terminal. So similarly, the transistor also we can use as a switch. Similarly, in the last topic we have completed in the switching modulator using diode. Similarly, we can also use transistor also we can use as a switching device. The applications of diode is as a rectifier, clipper, clamper, etc. Similarly, the transistor also we are using different applications like oscillator, amplifier, etc. The input and the output, now we will go to our topic. The input and the output relation of the non-linear device is given as V1 of t, means the input of the non-linear device, is equal to A into V1 of t plus B into V1 square of t. Here A and B are constant, means the value of A and B are constant. Substitute the equation 1 into, so we are getting V1 of t is equal to A into AM cos omega m into t plus AC cos omega c into t plus B into AM cos omega m into t plus AC cos omega c into t the whole square. So here we are using A plus B the whole square equation. So here A is equal to AM cos omega m into t and B is equal to AC cos omega c into t. So A plus B the whole square is equal to A square plus 2AB plus B square. So here we are using V1 of t is equal to A AM cos omega mt plus A AC cos omega ct plus B AM square cos omega m square t plus B AC square cos omega c square t plus 2 AM AC cos omega mt cos omega ct. So this is the output of the nonlinear device. So here we are using the nonlinear device as a diode or transistor. So here x of t and m of t are modulating signal or message signal. Both are connected and given to the diode is called as V1 of t, and the output of the diode we are representing as V2 of t. Then our V2 of t is given to the tuned circuit. Okay, in tuned circuit also there are different types available: single tuned circuit, double tuned circuit, staggered tuned circuit. But here using only concept of tuned circuit. Means a tuned circuit means it is the combination of L and C. L means inductance, C means capacitance, and the output is of the tuned circuit is given to the transformer. The output of the transformer is connected in the load resistor RL. So this is called as the output of non-linear device. So next one, band pass filter. So band pass filter is used to extract the desired signal from the output of non-linear device. We know that input of the non-linear device is the combination of message signal and the carrier signal, but the output of the non-linear device we are taking the output from diode. The LC tuned circuit act as a band pass filter. L means inductance, C means the capacitance. Both are acting as a band pass filter which is tuned to center frequency FC or carrier frequency or cutoff frequency, and it is bandwidth is equal to 2W. It allows only omega c plus or minus omega m and reject the higher order terms. This is the band pass filter. Finally, the output of the band pass filter is VO of t is equal to A AC cos omega c t plus B AM AC cos omega m into t cos omega c t. VO of t is the total output of the square law modulator, which is equal to A AC cos omega ct plus B AM AC by 2 into cos omega c minus omega m into t plus cos omega c plus omega m into t. So this is the spectrum of square law modulator. Here we are in x-axis we are representing the value of frequency, and y-axis is the output voltage or amplitude of the frequency signal, and in the positive side we are representing FC plus omega, that is called upper side band. FC minus omega, it is called as lower side band. Similarly, minus FC plus omega in lower side band, and minus FC minus omega in the upper side band. So here we are presenting, this is the spectrum or frequency spectrum of square law modulator. The output in terms of frequency domain is given by, means here we are finding the value with the help of LC tuned circuit. So the output of the LC tuned circuit VO of F is equal to A AC by 2 into del of FC minus F minus FC plus del of F plus FC plus B AC AM by 2 into M of F minus FC plus M of F plus FC. So this is the output in terms of frequency domain.